Alright, sorry about that. My computer froze, as you saw there at the end of that last problem we were doing. So, starting this problem over real quick, trying to factor, right? That's always step one. So I look at the numerator there, factors of -2 that add up to 2. There aren't any, so this thing doesn't factor, meaning nothing can cancel out of it. So there are no holes in this graph. Now, vertical asymptotes, we want to set the bottom equal to 0. So x plus 1 equal to 0 gives me the vertical asymptote x equals -1. So let's go ahead and plot that in here. -1, be right there. Horizontal asymptotes. So here we see that the top is bigger. Again, when the top is bigger, that means we do not have a horizontal asymptote. We could potentially have a slant asymptote though. So we want to look at our exponents here. We have x squared and x. So we're off by 1, meaning I do have a slant asymptote. So let's go ahead and do our division. So x plus 1, x squared plus 2x minus 2. So first term divided by first term leaves me with x. Distribute, we get x squared plus 1x. Changing my signs, negative, negative, x squareds cancel, and I'm left with 1x minus 2. So again, first term divided by first term. X divided by x leaves me with 1. Distribute, x plus 1. Again, this part's not that important. Minus, minus. That leaves me with -3, which is my remainder, which I don't care about. So here is my slant asymptote. So y equals x plus 1 is my slant asymptote. So we'll go ahead and do that. So thinking back to graphing lines, right? Y equals mx plus b. Here, my m, my slope is 1. So we have 1 over 1, rise over run. My b is positive 1. Remember, b is your y-intercept. So at positive 1, I'm going to go up 1 over 1. So I'm here, here, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then I just finish that going the other way. Okay, so there's my slant asymptote. X-intercepts. X-intercepts, we want to set the top equal to 0. Y-intercepts, we want to plug in 0. Now, that's a lot of math here since nothing factors, so we're going to use our calculator. So go ahead and pull up Desmos. Typing in our function here. On top we have x squared plus 2x minus 2. On bottom we have x plus 1. Okay. So my x-intercepts are here and here. So -2.73 and 0.73. My y-intercept is 0, -2. So let's go back and fill in all that information. So x-intercept, -2.730 and 0.730. So -2.73 and 0.73. My y-intercept was 0, -2. Puts me here. So left side of the vertical asymptote, I already have 1 dot. So let's find -2. And since -3 is so close to what we already have, let's go to -4. Just to kind of space out our dots a little bit. On the right side, I already have 2 dots. I have 0, almost 1. So let's just find 2. So going back to Desmos. Now, to pull up the table, if you hit this little gear here, we can hit this little convert to table, and it autofills it. So again, we just want to put in the information we want. So we want it to find -2, which it gives us there, and -4. So let's change that to -4. And then we want it 2. All right, so -2, 2, -4, -2, and 2, 2. So let's go put that information in, and we'll be done with this problem. So -2, 2, -4, -2, and then 2, 2. Man, it's a lot of 2's. All right, -2, 2, -4, -2. So here is the left side. Right side, 2, 2. And there's my graph. Okay, so that is our first example with the slant asymptote. Now, last problem. This is the most challenging problem we're going to look at today, and it has the weirdest looking graph, okay? So, again, start by factoring everything. So on top we have difference of cubes again. Our cube roots would be x and 1. So x1. Now thinking about your acronyms, SMS, square the first term, multiply the 2, so that'd be x, square the last term, which would be 1, and then SOAP for the signs. So same sign, opposite sign, always positive. On the bottom, we have difference of squares. The square roots would be x and 3, so x plus 3, x minus 3. Nothing cancels, so no holes, none. Vertical asymptotes. Again, we're going to have 2 vertical asymptotes. And again, remember what I said, when you have 2 vertical asymptotes, that's when you're going to have the funkiest looking graphs, okay? Because there's going to be stuff on the left, stuff in the middle, and stuff on the right. So setting my bottom 2 factors equal to 0, I get x equals -3 and x equals 3. Horizontal asymptotes. Look at the degree on the top to the degree on the bottom. I have x to the 3rd on top and x squared on the bottom. So again, top is bigger, which means I have no horizontal asymptotes. So I want to check to see, do I have slant? 3 on top, 2 on bottom, differs by 1. So I do have a slant asymptote. So let's go ahead and do that. Now, when I set up my division here, again, I need to put the placeholders in for terms that are missing. So on the outside, I start with x squared, and I need a placeholder for x, so plus 0x minus 9. On the inside, I need placeholders for x squared and x. So, first term divided by first term. Leaves me with x. Distribute, we get x to the 3rd, 0x squared minus 9x. Flip your signs. Cancels, cancels, we're left with a 9x minus 1. Now if I try and go again, 9x over x squared doesn't work. So this would be my remainder, which I don't care about. So here is my slant asymptote, y equals x. So let's put in all this information. So we have vertical asymptotes at -3 and 3. So -3 and 3. And then we have a slant at y equals x. So mx plus b, m is 1 over 1, and my b is 0. So I would be here, and then up 1 over 1, up 1 over 1. On and on and on. Going the other way. Okay. Alright, x-intercepts and y-intercepts. Again, looking at the top, I see I have x minus 1 as one of my factors. Setting that equal to 0 would leave me with 1, 0. I don't like how that's written. Let's make that skinnier. So 1, 0. And I don't know about the x squared plus x plus 1. That could give me zeros. I would have to use the quadratic formula though to figure that out, and I don't want to do that. So we're going to use Desmos. Same thing with the y-intercept. I could plug in 0, which wouldn't be too bad if I looked at the original problem, right? I would just have -1 over -9, which would give me 0, 1/9. And thinking about the decimal conversion of that, 1/9 is the same as 0.11111111111 forever. Okay? So I can go ahead and put that dot. That's nice and easy. And I have the x-intercept 1, 0, which is here. Again, remember, slant asymptotes are similar to horizontal asymptotes in that you are allowed to cross them. Okay? Remember, the only thing you can't cross is the vertical asymptotes. So, I need 3 x's on the left, 3 x's in the middle, 3 x's on the right. Left side, I don't have anything yet. Middle, I have 2 points. Right side, I have nothing. So, let's see if there are any other x-intercepts first. So, let's go to Desmos and type in our new function. Let's get rid of that one. So, we have x to the third minus 1. On bottom, we have x squared minus 9. So right now it doesn't look too bad, but I need to zoom this thing out a little bit to kind of get a clearer picture of what's going on. I see I only have one y-intercept and one x-intercept. Okay, so there's no other x-intercepts in the problem. So let's go back to here. So I have all the information I have right now. So I need 3 x values to the left of -3. So we'll use -4, -5, and -6. In the middle, I just need one more point. So we'll use -2. Why not? You could have done 2, -2, however you want to do it. On the right side, we'll use 4, 5, and 6. Alright, so let's go back to Desmos and check out our table. So if you hit the gear and pull up the table, so we want -4, -5, -6. We want -2, and then we want 4, 5, and 6. Alright, so there's all of our numbers there. Again, we're going to round to 2 decimal places, give or take. So let's go back to our table here. -4 was -9.28. -5 was -7.88. -6 was -8.03. -2 was 1.8. 4 was 9. 5 was 7.75. And then 6 was 7.96. So let's graph all of this information. So -4, a little bit past -9, -5, 7, almost to 8, so it'd be like right there. -6 was a little bit past 8, so I have this on the left side. It's a little rough. Try and round that out a little bit. In the middle, -2, 1.8, and that looks something like this. On the right side, 4, 9, 5, 7.75, 6, 7.96. Alright, so that is graphing with slant asymptotes. So we looked at graphing rational functions with removable discontinuities, right, having holes, having vertical asymptotes, either 1 or 2, having a horizontal asymptote or having a slant asymptote, and using Desmos to find the more complicated numbers for problems that aren't as nice. So that is that.